All right, so it says I have a graph of a function below. I want to compare f prime of pi over 2 with f double prime of pi with f of pi minus f of pi over 2 over pi minus pi over 2, and the integral from pi to 2 pi of f of x dx. Okay, so let's think of what each of these values are. So f prime of pi over 2, that's going to be some positive value. Okay, so that's the slope of the tangent line there. F double prime at pi, since it's concave down, f double prime at pi will be negative. And then f of pi minus f of pi over 2 over pi minus pi over 2, that will be this slope of the secant line, right? So f of pi minus f of pi over 2 over pi minus pi over 2 is going to be a slope. It's going to be positive, but it's going to be less than this one. Okay, and then for the last one, it asks for the integral from pi to 2 pi of f of x dx. So from pi to 2 pi, so we're going to add that positive area and that negative area. So that should be 0. Okay, so if I want to order them from, let's see. This ordering looks like from greatest to least. Oh, sheesh. Okay. So the biggest one would be f prime of pi over 2. And then that's bigger than f prime of pi. Oh, sorry. That's bigger than, sorry, this guy here. F of pi minus f of pi over 2 over pi minus pi over 2. And that is greater than 0, which is integral from 0 to 2 pi f of x dx. And that is greater than that negative one, which is f double prime of pi. Okay, let's see if one of those exists here. This one was first, then that one. No, yep, so B is the correct answer. So this is the area function from 0 to x of f of t dt. Which are the correct values of a of negative 2 and a double prime of 3? So a of negative 2, that will be the integral from 0 to negative 2 f of t dt. So from 0 to negative 2, so that'll be this area. Well, except the integrals are flipped, so it'll be negative of the integral from negative 2 to 0 f of t dt. So that is a rectangle with width 2 and height negative 4. So that'll be negative of 2 times negative 4. So this should be positive 8. And then a double prime of 3. Well, let's see. What is a prime of x? A prime of x, by the fundamental theorem of calculus part 2, will be the derivative with respect to x of the integral from 0 to x of f of t dt, which is equal to f of x. And a double prime of x should be f prime of x. So a double prime of 3 should be f prime of 3. So if I look at 3 here, I want this slope. So that slope will be over 1 up 2. So that'll be 2 over 1. Rise 2, run 1. Rise over run, 2 over 1. Okay, so a of negative 2 is 8. And a double, so these two are the, so a of negative 2 is 8. So these guys are out. So these two are the contenders. A double prime of 3 is 2, not 0, so it's E. Okay, the function is f of x equals sine of 2x. The numerical value of the expression that is equal to the area of the shaded region. Okay. The value of which of the following expressions is also equal to the area of the shaded region? Okay, boy. So this one I might notice looks like a, maybe you did a U substitution. Let's think about this. Integral from 0.2 to 0.8 of sine of 2x dx. If I let theta equal 2x, then d theta is 2 dx. So in order to get that 2 dx to show up, I need a 1/2 on the outside and a 2 on the inside. And so then I also need to know if x is 0.8, what is theta? Theta is going to be 2 times 0.8, so that'll be 1.6. And if x is 0.2, what is theta? Theta is 2 times 0.2, so theta is 0.4. So if I do my substitution, it'll be 1/2 integral from 0.4 to 1.6 sine of theta, because theta is 2x, and then 2 dx is d theta. So that one actually is the same because it's with a u substitution. If I look at the next one, this looks like a Riemann sum, but I'm just within rectangles. I don't have the limit as n goes to infinity, so that one is going to be an approximation within rectangles. What about this one? Negative cosine of... Okay. So that one, let's see here. So let's continue to solve this out. So what would this be? An antiderivative of sine is negative cosine. So 1/2 times negative cosine of theta. I'm evaluating that from 0.4 to 1.6. So that gives me a 1/2 times negative cosine of 1.6 minus negative cosine, so plus cosine of 0.4. So that is actually equal to that integral. So it'll be 1 and 3 only, d. Okay, this is the graph of a function y equals v of t is given below. The function v represents the vertical velocity of a car on a roller coaster in terms of the number of seconds elapsed. Okay, at the beginning of the ride, the car is 20 meters above the ground. How high does the car climb in the first 3 seconds of the ride? So what I want to do is the integral from 0 to 3 of my v of t dt. So I can see that that is this region here. So essentially I'm taking a velocity times time, and that gives me a distance. So I'm adding up pieces of distance from 0 up to 3. So if I just do that area geometrically, it's going to be 1/2 times the base, which is 3, times the height, which is 2. So that just gives me 3. So the car climbs 3 meters in the first 3 seconds. Okay, next, what is the car's height at t equals 6? So I need to do the integral from 0 to 6 of v of t dt. So how high does the car climb in the first 6 seconds? And so what I'll notice is that I'll definitely have that 3 that I had before. And then I also will have this region, which is going to be 2. So 1 times 2. And then this from 4 to 5 and from 5 to 6, that'll give me 0. So this is going to be equal to 5. But I know that it starts 20 meters above the ground. So the height at 6 seconds will be the original 20 meters plus the 5 that it has changed over the first 6 seconds. So it'll be 25 meters. For what value of t is the height of the car minimized? So if I think about my v using the first derivative test, the zeros of v are 5 and 6. And the car will be gaining height for the first 5 seconds. And then it will be losing height for the next 8 seconds. And then gaining height from 8 to 10. So that means that the position of the car is going to be increasing, then decreasing, then increasing again. So it would be minimized whenever, oh sorry, that's at 8, not 6. So it's 0 at 5 and 8. So v of t is minimized at t equals 8 by the first derivative test. What was the car's acceleration at t equals 9? So s double prime of t will equal v prime of t. So I want to evaluate that at 9 seconds. So v prime of 9. So at 9 seconds, that's here. What is my rise over run? So the rise is up a half over 1. So it'll be 1/2 over 1. So it'll be 1/2 meters per second. So if you could write that as meters per second squared if you want. All right, so for this one, I need to find, I'm going to evaluate this using the fundamental theorem of calculus part 1. So I need an antiderivative. So an antiderivative for 1 would be x plus an antiderivative for cosine x would be sine x. I want to evaluate that from 0 to pi. So this will be pi plus sine of pi minus 0 plus sine of 0. You can just leave it like that if you want. Well, let's see here. So sine of pi is going to be 0. Sine of 0 is 0. So you're going to actually end up with just pi here for your final answer. For the next one, I have e to the x minus 4 sine of x. So I need to find an antiderivative of that. So an antiderivative of e to the x is e to the x. An antiderivative of sine of x is negative cosine of x, so it'll be plus 4 cosine of x, and then plus c. So this is an antiderivative function for that. Here I want to do the derivative of this integral. So this is going to be the fundamental theorem of calculus part 2, but I'm going to have chain rule as part of it. So this will be, so the natural log x is going to go in for all the t's. So square root of 2 times ln of x to the 4th plus ln of x plus 1 times the derivative of ln of x is 1 over x. So that is chain rule. For the next one, I need to do a u substitution. So let's let u equal 5 plus 2x cubed. Then my du will be 6x dx. So I almost, 6x squared dx. So I have an x squared dx. Let's rearrange a little bit so I can see what I'm doing here. So I have the integral of square root of 5 plus 2x cubed. And then I have the x squared dx. So I'm just rearranging here. And then I need a 6 to appear, so I can multiply a 6 and a 1/6 on the outside. So now I have my du sitting right here. So I'm ready to do my substitution. So when I do the substitution, I'll get 1/6 integral of u to the 1/2, or square root of u, du. So when I take an antiderivative of that, the power is going to go up 1. So I'll have 1/6. I'll have u to the 3/2 times 2/3, and then plus c. So this will be 1/9 when I simplify that. And then my u is 5 plus 2x cubed plus c. Okay, so here's the next one. The function a of a is given by that function where x is positive. Determine the coordinates of the point of inflection of the graph. Okay, so what I need is a double prime. So what is a prime of x? Well, that's going to be the derivative with respect to x of the integral from 0 to x squared of square root of x minus 10 dt. Oh, sorry, square root of t minus 10 dt. So the derivative of that, I'll use chain rule. So it's going to be square root of x squared minus 10, and then times the derivative of x squared, which is going to be 2x. So the reason that it told me that this x is positive is that when I square root that square, I should be able to actually get a positive number. So this will be x minus 10 times 2x, which will be 2x squared minus 20x. So that's a prime. What's a double prime? Well, I just take the derivative again. So I'll get 4x minus 20. And then I can set that equal to 0 to find my possible inflection points. So I'll get x equal 5. And so if I look at my a double prime line, and I have 5 on here, if I plug in something to the right and left, so if I look at a double prime of like 6, that'll give me something positive. So 4 times 6 is 24 minus 20, which is 4. And a double prime of like 4, 16 minus 20, which is negative 4. So I get something positive on this side, it's something negative on that side. So that means that the concavity changes from concave down to concave up. So there actually is a change in concavity there. So the x coordinate of the inflection point is x equal 5. And I need to find the y coordinate. So I'll need to plug 5 into my original function. So a of 5 would be the integral from 0 to 5 squared of square root of t minus 10 dt. So that will be the integral from 0 to 25 of t to the 1/2 minus 10 dt. So now I can find an antiderivative of that. So it'll be t to the 3/2 times 2/3 minus 10t, and I want to evaluate that from 0 to 25. So when I plug 25 in that, I'll have 2/3 times 25 to the 3/2 minus 10 times 25. That's a really nice problem. And then minus, when I plug in 0, I'll just get zeros. So that value is the y coordinate of my inflection point. Let me plug that in the calculator real quick. Okay, so when I plugged that into my calculator, I got negative 500 thirds. So the coordinates of the inflection point are going to be 5, negative 500 thirds. Okay, so for the next one, it says that is a Riemann sum approximation for which of the following integrals? Okay, so it looks like from looking at this that each of my delta x is going to be 1/5. I have 30 rectangles, so 30 times 1/5 is going to be 6. So my interval is length is 6. Okay, so I know that. And I know my interval starts at 5. So my interval is from 5 to 11. So that's my interval, x equal 5 to x equal 11. So that's my integral. What is my function? Well, if I look back up here, I'm plugging these x values into a function here by raising it to the 7th power. So my function is going to be x to the 7th. So I'm plugging those x values into x to the 7th to get the height, multiplying by the width, which is 1/5. And so, so I should have the integral from 5 to 11 of x to the 7th dx. And that is d. Okay, so I know that the integral from 2 to 4 of f of x dx is 10. And the integral from 2 to 4 of g of x dx is -5. Which of the following cannot be determined from this expression? So integral from 4 to 2, that's the negative of the integral from 2 to 4, which is -10. So A is out. B. Oof. B does not look like something we could do. So I'm thinking B is a potential. Let's look at the others and just make sure. C, the integral from 2 to 4 of 7 gx, so that'll be 7 integral from 2 to 4 of g of x dx, which will be 7 times -5. So that one's out. We could do that. This one I can split up as integral from 2 to 4 f of x dx plus 5 integral from 2 to 4 g of x dx. So that one I can evaluate. Integral from 2 to 3 of f of x dx plus integral from 3 to 4 f of x dx. Well, I know that's going to be integral from 2 to 4 f of x dx. So I can evaluate that. So B is the only one that you can't evaluate. The next one, evaluate each of the following. Okay, evaluating some integrals. So that should be an antiderivative of that. The power is going to go up by 1. So I'll x to the 6th, and I divide by 6. The antiderivative of negative sign is positive cosine of x. And then plus an antiderivative of 5 to the x. So I know that the derivative of 5 to the x is going to be 5 to the x times the natural log of 5. So I should get 1 over the natural log of 5 to the x for an antiderivative plus c. Okay, this one. Okay, I'm going to need to do a u substitution. It might not be totally clear what substitution to do at first, but it might help if you think of this as the integral from 0 to pi over 2 of 1 over 1 plus sine of theta squared, then cosine theta d theta. So I'm going to let my u be sine of theta, and my du is going to be cosine theta d theta. But it might not be totally clear that that's the u substitution you need. If you try letting the whole denominator be u, you're going to get something messier for your du. But here I have my du, well, it's already there, sitting there. Then I have 1 over 1 plus, it's going to be u squared. So that's going to be an arctangent. I do need to change my bounds though. Sine of 0 is 0. Sine of pi over 2 is 1. So I'll have the integral from 0 to 1, 1 over 1 plus u squared du. So I'm ready to change it over. Now I can evaluate this. So this is going to be arctan of u evaluated from 0 to 1. So this is arctan of 1 minus arctan of 0. So that's going to end up being, well, the angle that has slope 1, because the tangent is the slope, right? So the angle that has slope 1 is pi over 4 minus the angle that has slope 0 is 0. It's going to be pi over 4. You could leave it like this if you want. Okay, so for this one I have the derivative of this integral. So again, it's going to be fundamental theorem of calculus part 2, interacting with chain rule. So it'll be the natural log of 4 times, I'm going to plug that in for t, square root of x, times the derivative of square root of x, which will be 1/2 x to the negative 1/2. So that's the derivative of that integral. Number 8 says the graph of that function is given below. Notice that f is defined for everything in the interval from -5 to 5. Define a of x by this. It's from 0 to x. Evaluate a of 1 and a of -3. So a of 1 will be the integral from 0 to 1 of f of t dt. So that will be this area here. So it'll be a rectangle 1 times -3. So that's area is -3. A of -3 will be the integral from 0 to -3 f of t dt, which will be negative of the integral from -3 to 0 f of t dt. So I'm going backwards now with my area. So that integral will be a negative area. It looks like a trapezoid, or I can think of it as a rectangle and a triangle if you want. And so we get, this will be -3, 1, 2, 3 boxes, and then this will end up being 1/2 times 2 times -3. So this will be negative of -3 minus 3, so it'll be +6. For what values of x on the interval -5 to 5 does a of x have a local maximum? So remember that a prime of x is equal to f of x from the fundamental theorem of calculus part 1, and so I can make my a prime line. So a prime will be 0 when f is 0. So that's here and here. So my critical points are at -3 and at 4. So a prime is positive. It's above the x-axis here and here. And a prime is negative or below the x-axis here in the middle. So that means that a is increasing, and then a is decreasing, and then a is increasing. So a local maximum will occur at x equal -3. Then it says find a prime of 1. So a prime of 1 should be f of 1. Because remember, a prime of x is f of x by the fundamental theorem of calculus part 1. And so f of 1 is -3. And a double prime of 4 should be f prime of 4. So if I look at 4, what is the slope there? That might not be simple. Let's see here. So the slope is the slope of this line. So the rise is, well, so maybe we'll go from this point to this point. So it's up 3 over 2. So rise is 3, run is 2, so 3/2.